All right, Algebra 2, welcome to the video for your work this upcoming Tuesday, March the 16th, when I will be out of the classroom. All right, it is looking at game plan 7174 here. You can look at your quiz review as well. 6567 quiz will be the next day on Wednesday. All right, so be ready for that. So let's talk about Tuesday's video. In this game plan, we are going to go first to page 8. Page 8 is section 7.3. Section 7.3, let's zoom in here. All right, so we're going to go from exponential to log form. All right, so log base A of B equals x means the following. It means a to the x power is equal to b. So this is a subscript and it's the base. This is what I call the answer, and the right side of the equal sign is the exponents. All right, so log base A of the answer b equals x. So if I have 5 to the third equals 125, it would be log base 5, because 5 is the base, of the answer 125 equals the exponent 3. If I have 7 squared equals 49, I'll have log base 7 of the answer 49 equals the exponent 2. If I have 5 to the negative second equals 1 over 25, it is going to be log base 5 of the answer 1 over 25 equals negative 2. Both the base and what we call the answer have to be bigger than 0. This can be anything. Log base 8 of the answer 2 equals the exponent 1/3. Log base 17 of the answer 1 equals the exponent 0. And finally, log base 12 of the answer 12 equals the exponent 1. All right, it's pretty easy to go from exponential to logarithmic form here. So if I have 3 to the 4th equals 81, it's going to be log base 3 of the answer 81 equals 4. Again, the exponent is on the right side of the equal sign. The exponent is on the right side of the equal sign when we write it in logarithmic form. So log base 7 of the answer 343 equals the exponent 3. Log base 5 of the answer 1/5 equals negative 1. Log base 100 of 10, so this answer is not always bigger. It's written bigger, like bigger font and whatnot. If we type this is always, the subscript is always written smaller, you know, like when you read it on a better published page here, equals the exponent 1/2. Log base 27 of the answer 3 equals 1/3. Log base 1/4 of the answer 16 equals the exponent negative 2. Log base 2 of the answer 32 equals 5, the exponent. Log base 10 of the answer 1000 equals 3. Also, your calculator, the log button, if there's no base shown there, which your calculator doesn't, it's implied 10. So log 1000, that's log base 10. If you type in log 100 in your calculator, it's going to say 2. Log 10, it's going to say 1. If you just see something that says log, the implied base is 10. All right, go from log to exponential form. So 2 to the 4th power equals 16. These are easy to check because it should make a true statement. 2 to the 4th is 16. You can check it. 4 to the 3rd power equals 64. 81 to the 1/2 power is 9. That's because the square root of 81 is 9. The 1/2 power is the square root. 3 to the negative second is 1 over 9, because 3 to the negative second is 1 over 3 to the second. 3 to the second is 9. All right, page 8 is a pretty easy one for us. Let's go to page 9 here. Evaluate each expression. So we're going to set all of these equal to x. We're looking for the exponent here. So 3 to what power equals 27? It's 3 to the 3rd. 2 to what power equals 32? That's the 5th. All right, so log base 5 of 125 equals x. 5 to the x power equals 125. X is 3, and that is the name of the game. For most of these, we'll do some of them together. on Thursday. 4 to the what power is equal to 256? That power is 4. 12 to the what power is equal to 12? That power is 1. Here's an exponent rule from pre-algebra. 7 to what power is 1? Well, x to the 0 power is 0. All right, so this power would have to be 0. This is an interesting one. 49 to what power is equal to 7? Well, the square root of 49 is 7, so x is the 1/2 power. I can make 49 into 7 squared. When I raise that to the x power, I have 7 to the x power equals 7 to the first. So if the bases are the same from earlier, then the exponents, 2x, must equal 1. X is 1/2. That's another way to get 1/2. So 3 to what power gives you 340 or 243? That's 5th power. We'll do 17 together in class. 9 to what power gives you 3? I'm going to call 9 3 squared. A power to a power, I multiply. 3 to the 2x equals 3 to the first. 2x is 1. X is 1/2. All right. 17 to what power gives you 289? X is 2. 7 to what power is 343? X is 3. This is page 9. We will finish the rest together. Page 10. Let's write these that are written in logarithmic form. Let's put them in exponential form. So 25 to the 1/2 power is equal to x. That's the square root of 25. X is 5. 4 to the 3rd equals x. X is simply 64. Again, writing this in exponential form, x to the 5th power equals 32. X is 2. 3 to the 4th power equals x. X is 81. 2 to the 4th power is 16. X is 16. 9 to the 3/2 is x. What? Again, your calculator can do 9 to the 1.5. But here's what we can also do in our head. The second root, the square root of 9 is 3. So I would do 3 then to the 3rd power. That's how I wrote 3 to the 3rd. That's 27. We have more of those fractional exponents here. 16 to the 5 over 2 is equal to x. The square root of 16 is 4. 4 to the 5th power is 1,024. 8 to the 4/3 is equal to x. The 3rd root of 8 is 2. 2 to the 4th, 16. And 16 to the 3/4 is x. 4th root of 16 is 2. 2 to the 3rd is 8. 5 to the what power is 125? That power is 3. All right, this is page 10 and again, page 12. Page 12 here, that is on your own. That's pretty easy. What do you got? Growth or decay, like on 26. Base is less than 1. You have decay. Move the decimal over twice. That's 87.5. And if it's decay, subtract it from 100. That is a 12.5% decay. Something like 31 is growth. The base is bigger than 1. You got growth. Move the decimal over twice. That's 2.5% growth. Be careful on 29. This is decay. It's less than 1, so that's easy. But if you move the decimal over twice, that's 99.8. If you subtract it from 100, that is 0.2% decay. Goodness. All right. So page 12 is going to be on your own. Then we'll do 13 together. If we have not, this is the last page here, page 14 in this relatively quick game plan. This is going to also be something you used to be some points in the past, just part of your game plan here, a little pre-test. State whether each function represents or shows exponential growth or decay, and state the percent growth or decay. The base is bigger than 1, so it's got to be growth. If you move the decimal over twice, 103.4, 3.4% is the bonus or the growth. It's decay. The base is less than 1. Move it over twice. That's 94.3. Subtract 94.3 from 100, 5.7% decay. Move the decimal over twice, 6.5% growth. The base is bigger than 1. Number 4, the base is less than 1, so it's got to be decay. Move it over twice, 92.5. 92.5 subtracted from 100, that's 7.5% decay. Number 5 is growth. Base is bigger than 1. Move that over twice, 9.4% growth. 6, base is bigger than 1, it's growth, 12.3%. Write each exponential equation in logarithmic form. So log base 4 of the answer, 1024, is equal to the exponent 5. Log base 3 of the answer, 1 over 81, equals the exponent negative 4. Log base 49 of the answer 7 equals 1/2. Go the other way. 2 to the 7th power equals 128. 27 to the 1/3 power equals 3. 5 to the negative 2nd is 1 over 25. And this is everything you need to get accomplished on Tuesday, March 16th. This is Yak Math Videos signing out.